Question 4, part A. Show that the binomial expansion of 1 plus 5x to the power 1/5 up to and including the term in x cubed is, and they gave us an expression of what we should get. Now we have a power that's a fraction, so it's best we use this formula, 1 plus x to the power n is 1 plus nx plus n into n minus 1 x squared over 2 factorial plus n into n minus 1 into n minus 2 x cubed over 3 factorial. So here we're going to replace x with 5x and replace n with 1/5 in the formula. So we are calculating 1 plus 5x to the power of 1/5. So replace n with 5, replace x with 5x and n with 1/5. So it's 1 plus n, we're replacing n with 1/5 times x replaces x with 5x plus here, and this will be the third term now, n is 1/5, so 1/5 into 1/5 minus 1 x squared. Remember we're replacing x with 5x, so 5x all square over 2 factorial, which is 2 times 1, which is 2. Final term, 3 factorial in the denominator, 3 times 2 times 1, that's 6. So n, that's 1/5 into 1/5 minus 1 into 1/5 minus 2 times x cubed, but remember we're replacing x with 5x, so x cubed becomes 5x cubed, so 5x all cubed. So we end up with 1 plus, now 1/5 of 5x, that's x, plus, so 2, we have 2 in the denominator here. Now 1/5, so we can use our calculator for this. So here we have 1/5 times minus 4/5 times 5, actually times 25x squared. So the first, so we have 1/5, and then 1/5 minus 1, that's negative 4/5 times 5x squared, that's 25x squared. 5x times 5x plus, and here we have 1/5 times negative 4/5, and then 1/5, what's 1/5 minus 2? Remember 2 is negative 10 over 5, so that's negative 9/5. Well, negative 2 is negative 10 over 5 times 5x cubed, and 5x cubed will be 125. 125 x cubed. 5x cubed, 125 x cubed. 1/5 minus 2, that's negative 9/5. So let's simplify and let's see if we get what they tell us that we should get. So this is 1 plus x, and then here now, this is, so okay, so 25, 5 times 5 is 25 into that. That's 1, negative 4 divided by 2. So that's negative 2x squared. And then this final term here. So we have 125. 5 times 5 times 5 is also 125. So we're left with minus 4 times minus 9. That's 34. That's 36. And then 36 divided by 6. That's 6, so 6x cubed. So the proof is done. Let's move on. By letting x equal negative 1 over 32, compute an estimate for the fifth root of 27. So we just found 1 plus 5x, at least the term up to x cubed. 1 plus 5x to the power of 1/5. We just found the first 4 terms to be this. Now let us replace x with negative 1 over 32. So this becomes 1, and then it's 5 times minus 1 over 32. So that's 1 minus 5 over 32 equal to, and we're going to replace all our x values with minus 1 over 32. So this becomes 1 minus 1 over 32 minus 2 times minus 1 over 32 all square plus 6 times minus 1 over 32 all cube. Now 1 minus 5 over 32, so of course 1 is 32 over 32. So 32 over 32 minus 5 over 32, that gives me 27, well, to the power 1/5. That gives me 27 over 32. That's where S7 meter to the power 1/5. Of course, the power here is 1/5, right? This is equal to, now we can use our calculator and work out everything on the right hand side. I am getting 0.96698. Actually, your scientific calculator should be able to do that. And so now we can, indices, we can take the fifth root. We can take the fifth root of the denominator of each, by the way, of both the numerator and the denominator. So the fifth root of 27, we can write it as that, the fifth root of 27. And we take the fifth root of the denominator, the fifth root of 32 is 2, equal to 0.96698. Now we can times both sides by 2. So we times the left hand side by, so we times both sides by 2. So 2 into 2. So end up with the fifth root. The fifth root of 27 equal to 2 times what we have on the right hand side here. I am getting 1.934. So the fifth root of 27. Right. That's what we're asked to find. And that's that. Part B. Use the intermediate value theorem to prove that 4e to the x plus 2x squared minus 5 equals 0 has a root in the interval 0, 1. So we can let f of x equal to the function there, 4e to the x plus 2x squared minus 5. We can find f of 0. Now f of 0, replace x with 0, so you get 4e to the 0. Well, minus 5, because this will become 0, and this will become 4e to the 0 minus 5. Will become, well, e to the 0 is 1, so is 4 minus 5, that's negative 1. So we can also find f of 1. F of 1, we're replacing x with 1 now, so that's 4e to the power 1 plus 2 times 1 to the power 5, which is just 2, minus 5, and this gives us positive 7.87, I'm getting. So notice f of 0 times f of 1 is equal to negative 7. So f of 0 is negative 1, f of 1 is 7.87. Multiply them, we'll get negative 7.87, which is less than 0. So therefore, by the, I just abbreviate in here, the intermediate value theorem, a root lies on the interval 0, 1. Same as saying the root falls somewhere between 0 and 1. So we expect the root to be 0 point something. Next, use 4 iterations. Use 4 iterations of the interval bisection method to calculate an approximation to the root 4e to the, so the same equation here, 4e to the power x plus 2x squared minus 5 equals 0. So let the function be the same thing. So we know the root lies between 0 and 1. So we're going to bisect the interval here. So the first bisection is 0.5. So we're going to find, so remember, let's remember f of x was whatever the function is, 4e to the x plus 2x squared minus 5. So we find f of 0.5, replacing x values with 0.5. So f of 0.5 will be 4e to the 0.5 plus 2 times 0.5 square minus 5. My calculator has given me 2.1. So by the way, f of 0, let's remind ourselves what f of 0 was. F of 0 was a negative number and f of 1 was a positive number. So f of 0 was a negative number and f of 1 was a positive number. So we know the root lies between 0 and 1. Alright? Now f of 0.5 give us, the value is not really important. What's really important is the sign. F of 0.5 give us a positive number. So we know the root lies between 0 and 0.5. Since f of 0 and f of 0.5 give us different signs, which means if we take the product of f of 0 and f of 0.5, we'll get a value which is less than 0, a negative value. So we know the root lies between 0 and 0.5. So we're going to bisect 0.5. We're going to bisect 0.5. And with bisect 0.5, we get 0.25. So let us now find f of 0.25. And this is our f of 0.25. Alright, so f of 0.25, in f of x, we're replacing x with 0.25. So we end up with 4e to the 0.25 plus 2 times 0.25 square minus 5. And we can just enter that in your calculator as it is. We're getting 0.26. So f of 0.25 is a positive value. So again, we know the root lies between 0 and 0.25. So this time we're going to bisect. We're going to bisect now 0.25. We get what now? 0.125. So we bisect 0.25. We'll get 0.125. Let's now find f of 0.125. So f of 0.125, replace x with 0.25 in the function. So it's 4e to the power of 0.125 plus 2 times 0.125 square minus 5, and I am getting negative 0.4. Alright, so f of 0.25 giving me a negative number. So we know the root lies between 0.125 and 0.25. So the root lies between 0.125 and 0.25. So we're going to bisect 0.125 and 0.25. We're going to average them. We'll get 0.1875. So next root we're going to try is 0.1875. So this time we're going to, in the function, replace x with 0.1875. Alright, so we'll now have 4e to the 0.1875 plus 2 times 0.1875 square minus 5, and I am getting negative 0.1. So this interval here is, when we have 0.1875, it's a negative number. So it was negative number. So the root lies between 0.1875 and 0.25. So final iteration that we're asked to do 4, right? So 4, we're asked to do 4. So the root, or an approximation to the root is, we just average, we know it's between 0.1875 and 0.25, so we're going to average those numbers. Alright? We're going to average 0.1875 0.75 and 0.25. Average those, we'll get point where we told the amount of decimal points to use. No, let me use 3 decimal places. 0.218, 0.219, 0.219 to 2 decimal places. Let's continue. So we have the same function, and we are also use 3 iterations of the linear interpolation method to approximate the root of the same equation, and this time it's another root. This time the root is in the interval -2, -1. So this equation obviously has more than one root. So this time now the root, we are told the root lies between -2, something looking like a number line there, -1. Alright? So we just assume, I guess we're not asked to show using the intermediate value theorem. We just assume the root falls between -2 and -1. Alright, so we're going to use so the first approximation is for the linear interpolation. The linear interpolation formula, we use a formula that says so the formula f of a, modulus of f of a, b times the modulus of f of a, plus a times the modulus of f of b, all over the modulus of f of a plus the modulus of f of b. Alright, so a will refer to the -2 as a, and this will be the upper one. -1 is bigger than -2, right? So we refer to that as b. So let's find f of a. Alright, so f of a, so we're using the -2 as a and the -1 as b. Now f of a, let's find f of -2, which would be same as f of a. So now f of a, using this, let me put it up here. F of a f of -2, just replace x with -2, so f of will be 4e to the -2 plus 2 times -2 square minus 5, and that will give us 3.541, and f of -1, this time we're replacing x with -1, so it'll be 4e to the -1 plus 2 times -1 square, replacing x with -1, minus 5, and I am getting 1.528. Alright, so notice, so f of -1, that's not it. It's actually a minus. And if you notice f of -2 and f of -1 have different signs, so we know our root lies between -2 and -1, because if you should take the product of one negative number and one positive number, the result will be less than 0. Alright? So we know the root lies between -2 and -1. Alright, so let's substitute these into the linear interpolation formula. Alright, so the formula, so we have, so x1 is equal to, now b, we are using b to be -1. Alright, so we're using b to be -1. So -1 times f of a, remember a was -2. So f of a would be 3.541. This thing keeps jumping all over the place. F of a will be 3.541 plus a is a lower interval here, which is -2, times f of b. F of b was f of -1, and we found that would be -1.528. Remember, we're taking the modulus, so the positive 1.528, we use a positive value, all over f of a, which is 3.541, plus f of b, which is 1.528, and we can use our calculator to do this calculation. So we end up with negative 1.301. So you can pause the video, use a calculator, and do that calculation there. Alright, so the first iteration, that's the first use of the formula, is telling us that the root would be negative 1.3, negative 1.301. That's what the first iteration telling us. Alright. So to the second iteration, we need a new interval. So to get a new interval, we need to find f of minus 1.301, and the signs will indicate to us which interval we'll use for the second iteration. All right, so let's find f of minus 1.301. So f of minus 1.301 will give us, and this time we're replacing in the formula, we're replacing x with negative 1.301. So 4e to the x, so 4e to the negative 1.301, and then what else we have? 2x squared minus 5. So plus 2 negative 1.301 square minus 5, and this is equal to minus 0.526. All right, minus 0.526. So notice f of negative 1.301. So f of negative 2. F of negative 2 was a positive value. F of negative 1. F of negative 2 was a positive value. F of negative 1 was a negative value. F of negative 1.301 give us a negative value, negative 0.526. So it gives us a negative value. So we know the root will lie between, between minus 2 and what the first iteration gave us, which is minus 1.301. So the b value we're going to be using now, we're going to use a different b value now. We're going to use b equal, this is the upper interval now. So this is our new b value. So we're going to use the formula again. Second iteration this time, but this time our a value is minus 2, our b value is negative 1.301. So let's use the second iteration. So x2, again, we're using the same formula. So this time b is negative 1.301. Times f of a. Now the a is the same, so everything for f of a will remain the same, which is 3.541. Plus, and again, a is minus 2, so minus 2 times f of b. Now we found f of b to be negative 0.526, but remember we are using the modulus, so we use a positive value, negative, so 0.526 all over, and we sum f of a and f of b. So f of a, again, 3.541 plus f of b, we're using a modulus, 0.526, and you can just pause and use your calculator. I'm getting negative 1.391. So the second iteration is giving us negative 1.391. Negative 1.391. So negative 1.391 will be somewhere here. So negative 1.391. All right, let's find f of negative 1.391 to find a new interval to do the last iteration. So f of minus 1.391. So in the function, we're going to replace this time x with negative 1.391. So we'll have 4 e to the minus 1.391 plus 2 into minus 1.391 all square minus 5, and my calculator has given me minus 0.135. So f of minus 1.391 is giving us a negative value. So we know the root lies between minus 2, since f of minus 2 is positive, and f of minus 1.391 is negative. So we know the root lies between these two values. So when I do the final iteration, this our b value is going to change again because the upper interval. So so this is now our b value. Notice the a value is still the same. Alright, so the upper limit is minus 1.391. So we're going to use the final iteration, the third and final one. This time, so fx subscript 3. Again, same formula we're using. It's just that this time b is negative 1.391 and a is a lower limit there at minus 2. So b negative 1.391, same formula, minus 1.391 times f of a, and f of a doesn't change. F of a is still 3.541 plus a, and a, remember a is minus 2, the lower limit there, so a is minus 2, and we found f of b to be negative. Remember b was negative 1.391, and f of that will be well, we're taking the positive, right, modulus, so 0.135, and this is all over f of a plus f of b, the positive, the modulus of 3.541 plus 0.135. We do this calculation. The third iteration will give us negative 1.413. Let's continue. Question 5. It's a matrix problem. A matrix P is given as P equal to that. Show that the determinant of P is 183. So I'm going to use a cofactor method to find the determinant of P. Alright, so the determinant of P, I'm going to use a cofactor method. So 4, I will find the cofactor of 4, which is 4, 15, 10, minus 3. Then we'll change sign, so minus 3, change the sign. If it was minus 3, you would have put positive 3 here, right? And the cofactor, to get the cofactor of 3, you cross out the row the column is, the 3 is in, you cross out the column the 3 is in, you're left with 9, 15, 12, negative 3, plus 5 times its cofactor, and the cofactor of 5, to get the cofactor of 5, you eliminate the row the 5 is in, and the column that the 5 is in, you're left with 9, 4, 12, 10. Let's do this calculation now. So this is equal to 4 into our cross multiply and subtract. So minus 12, and then 10 times 15, that's minus 150. Minus 3, cross multiply and subtract, so that's minus 27. And what's 12 times 15? We get minus 180 plus 5. Cross multiply and subtract, 9 times 10 is 90. Take away 4 12s. That's a 48. So we can do this. So this is minus 648. This is 621 plus 210. Calculator can do all of this in one go. Alright. So this should be 183. Alright. So we just show what we're supposed to show. Next, hence or otherwise, show that the adjoint of P is, and they'll give us the matrix it's supposed to be. So the adjoint of P, so the adjoint is just the transpose, it's just the matrix of cofactors. So it's a transpose of a matrix of cofactors. Alright? And how do we get the matrix of cofactors? We simply replace all the elements in P with its cofactor. Let me just draw a large matrix here. And we're going to replace all the elements in P with its cofactor. Let's remind ourselves what P was again. P was a matrix 4, 3, 5, 9, 4, 15, 12, 10, negative 3. Let's just rewrite it. I'm going to need to be looking at P while I'm getting the adjoint. So P was a matrix 4, 3, 5, 9, 4, 15, 12, 10, minus 3. I'm going to need this right here. Alright, and how do I get the matrix of cofactors? I'm going to replace each element with its cofactor. So for the element 4, how do I get the cofactor of 4? You cross out the row that the 4 is in, you cross out the column the 4 is in. What are you left with? 4, 15, 10, negative 3. And you're changing signs, alternating signs while you're doing so. The cofactor of 3, do the exact same thing. Cross out the row, the 3 is in. Cross out the column, the 3 is in. You're left with 9, 15, 12, negative 3. I'm going to look faster now. The cofactor of the 5, that's 9, 4, 12, 10. So you can pause the video and write out all your cofactors. The cofactor of 9, remember alternating signs as well we do this. The cofactor of the 9 is 3, 5, 10, negative 3. The cofactor of the 4 is 4, 5, 12, negative 3. Alternating signs. The cofactor of the 15 is 4, 3, 12, 10. The cofactor of the 12 is 3, 5, 4, 15. The cofactor of the 10 is 4, 5, 9, 15. Alternating signs while we are doing so. And the cofactor of the negative 3, that's 4, 3, 9, 4. Four, 3, 9, 4. Alright, let's find the determinant of each of those values we have there. Now, of course, it transpose. What is a transpose of the matrix of the cofactors, right? Alright, so the first one, minus 12 minus 150, that's minus 162, so we will cross multiply and subtract, right? Next one, that's what now, cross multiply is minus 27, minus 12 times 15, we get 207, no, we get 59, actually negative 207 and minus, so that's positive 207. Right, next one, that's 90 minus 48, that's 42. Next one, that's minus 9 minus 50, that's minus 59. Apply the negative, it's positive 59. Next one is minus 12 minus 60, that's minus 72. Next one is 40 minus 36, that's minus 4. The final row, 3 times 15, that's 45, minus 20, that's 25. Next one, 4 15, that's 60, minus 45, that's 15. I'll apply a minus, that's minus 15. And the final one, that's 16, minus 27, that's minus 11. So we're going to take the transpose now, where with the transpose, the rows become columns, right? So this would be minus 162, 207, 42. Next one, rows become column, is 59, minus 72, minus 4, and the final one is 25, minus 15, minus 11. And this is exactly what we're told that we're supposed to get, all right, for our adjoint of P. Let's continue. Solve a system of linear equations. Note we can just call this matrix A. This is the matrix A matrix we have been working with. We just found the determinant for it, and we also found the adjoint for this matrix. So if we call this matrix A, we can pre-multiply both sides by A inverse. So A inverse times the left, A inverse times the right. So A inverse times itself, we get the identity matrix. So on the left, all we have is XYZ. I times XYZ, and I is equivalent to 1. Alright? And on the right hand side, A inverse, remember A inverse is 1 over the determinant. Remember A inverse is 1 over determinant of A times the adjoint of A. Now for this very same matrix A, we found the determinant. Now we found the determinant to be 183. So it's 1 over 183. And we just found the adjoint. Alright, we just found the adjoint. Here's the adjoint. We just prove the adjoint. And we're actually given the adjoint and asked to prove it. The adjoint minus 162, 59, 25, 207, negative 72, negative 15, 42, minus 4, minus 11. So the adjoint, let me just restate all of those values. So the adjoint would be minus 162, 59, I think I need more space, 25, and we have what now? 207, negative 72, negative 15, and we have 42, minus 4, minus 11, times, so A inverse times 11, 13, 4. So therefore, XYZ is equal to, let me keep 1 over 183, and then do the expansion here. So we're multiplying a 3 by 3 by a 3 by 1, so we should get a with a 3 by 1. So let's row by column. So minus 162 times 11 plus 59 times 13 plus 25 times 4. Second row by the same column. So 207 times 11 plus negative 72 times 13 plus minus 15 times 4, and the final row 42 times 11 plus minus 4 times 13 plus minus 11 times 4, and we can use our calculator to each of them. So we have xyz is equal to 1 over determinant into the top row, work out to minus 915. The second row, work out to 1281. And the final row, work out to be 366. So this means that xyz is equal to, so you multiply, well, divide each term in the bracket, in each term in the matrix by 183. So we end up with minus 5, 7, and 2. So therefore, x equal minus 5, y equal to 7, and z equal to 2. Let's move on. Alex has 5 blue marbles, 4 green, so 5 blue marbles, 4 green marbles, 3 red marbles. In how many ways can he arrange 4 marbles in a row if the marbles of any given color are identical? So the marbles, whichever color, must be the same. So the 4 marbles, my interpretation here is 4 marbles, and all the 4 marbles must have the same color, identical color. Alright, so 4 marbles must be in a row, arranged in a row, and all of them must be identical. Alright, this is a simple question. Alright, so of course, for the first, so he's lining up 4 marbles. So for the first marble, there are three different possibilities. Alright, so 3 times this in the second marble. So even if the first marble is a blue, in the second option, again, 3 possibilities. If the first one was a green, second option, 3 possibilities. So the first marble, whatever color, 3 possibilities. The second marble, whatever color, again, 3 possibilities. The third marble, whatever the color, because remember it's 5 blue marbles now. So even if the first 2 marbles were blue, the third marble is still can choose blue. Even for same with green, 4 green, so even if the first 2 marbles were green, the third one can be green also. And even if the first 2 were red, the third can be red also. So the third marble, 3 options again. And then the fourth marble, well, 3 options except 1. So 3 options, but of course, you won't be able to get 3. So we're going to minus the possibility of the 4 red. This option would be out, because remember it's only 3 red marbles. So the number of arrangements in how many ways? So the number of ways will be 3 times 3 times 3, so 3 to the power 4. But of course, we'd have to subtract this option, because this option would have to rule out. There's no possibility of getting 4 red marbles. So we subtract that one. So that's 81. Yes, 9 square, 81 minus 1. So 80 ways. Let's move on. Let A and B be 2 events such that probability of A is a half, probability of B is a quarter, A intersect B is 1/8. So this question, I think this question will need a diagram with it, probably, maybe not. Let's draw a diagram to represent the situation here. So we have A, we'll call this A, and let me call this B. So let me do the intersection first. So A intersect B, that's 1/8. I always go to do the intersection first. And the probability of A is a half. No, A is a half, so half is what? 4/8. Let's look at the half as 4/8. So this is 4/8 minus 1/8, so 3/8. And just double check. So for A, if you add up A, you still get 4/8, which is still a half. And for B is a quarter. And a quarter is 2/8, right? So B is a quarter is 2/8. So you subtract the intersection, you get 1/8. So again, just to check, probability of B, here's 1/8 and 1/8, that's 2/8, which is a quarter, right? If you add up all of these, A union B, you end up with 5/8, which means that 3/8, remember everything must add to give 1. Alright? Probability, so 3/8 will be neither A nor B there, right? So what are we asked to find out? The probability of A complement union B complement. So we have a formula there. So the probability of A complement union B complement is the probability of A complement plus the probability of B complement minus the probability of A complement intersect B complement. All right, let's do this now. So A complement, no A is, if you look at A, you can look at 2. You can look at this A is a half. So A complement will be 1 minus a half. If you look at the diagram, A complement is everything outside of A there, right? Which is 1/8 and 3/8. That's a half. All right. B complement, you can even use from this. A B complement should be 3/4. But if you look at the diagram here, B complement is everything outside of B, which is 3/8 and 3/8. That's 6/8. Same as 3/4, right? Minus, no, this one is a tricky one now. A complement intersect B complement. If you look at A complement, look at A complement, we have 1/8 and you have 3/8. If you look at B complement is just 3/8. Alright, so it's really just 3/8. Intersection is what both of them contain. Alright, which is just 3/8. So this would be 3/8. Remember, intersection would be what is common to both sets, right? What is common to A complement and B complement is 3/8. Alright, so half plus 3/4 minus 3/8, that will give us, so half is 4/8. 3/4 is 6/8 minus 3/8. 4/8 and 6/8, that's 10/8 minus 3/8. I'm getting 7/8. 7/8 for my answer. Let's continue. Question 6. This is a conditional probability problem. The probability of A given B, the formula there, is the probability of A intersect B over the probability of B. Alright, the probability of A, let's look at now. So this is A, color line is A, and men is B. So A intersect B will be this, 0.04 divided by, and the probability of B, well, B is just men, which is 0.51. So it's 0.04 divided by 0.51. Next, calculate the probability that a member of the population selected at random is colorblind. So let's go back to the, so colorblind is colorblind. That's in this top row here, 0.042. So this is just 0.04, oh my, 0.042. Next, solve the differential equation given that when y is 0, x is equal to pi. So we're going to use the integrating factor method. So we're going to divide. So we have x squared dy by dx plus 2x y equal cos x. So we're going to divide everything by x squared. Since we want the coefficient of the dy by dx to be 1, so divide this term by x squared, we get dy by dx. Divide, so 2x divided by x squared. So divide by x squared, divide by x squared, and divide by x squared. Alright, so end up with 2 over x y equal cos x over x squared. Now the integrating factor is e to the integral of the y coefficient, which is 2 over x dx. So that's equal e to the integral of 2 over x, that's 2 log x. And 2 log x we can rewrite as log x squared. E to the log x squared is just x squared. So the integrating factor is x squared. Alright, so we're going to multiply this differential equation by the integrating factor, which is x squared. So x squared times each term, we're not with the original thing, so x squared times that, we get x squared dy by dx. So we'll multiply that by the integrating factor. We get x squared dy by dx. Multiply this times x squared, we get 2xy. And we get this times this, we get cos x. Same as the original equation. Alright, and after we do this, we're going to integrate both sides. We're going to integrate both sides with respect to x. So integrate the left hand side, as always, the integrating factor times y. And if we integrate cos x, we get sin x plus our constant c. But remember, we were told that when x is pi, y is 0. So we're going to substitute. So remember, when x is pi, y is 0. So replace x with pi. So this becomes pi square times y. So this is 0. And here we'll have sin pi plus c. No, so this is just 0 equals sin pi 0. So c 0. So therefore x square y equals sin x. And if I transpose in for y, divide both sides by x squared. So x squared into itself, that's 1. So y equal to sin x over x squared. Now we're on to the final section of the paper, which is part C, question 6, part C. So second order differential equation. Alright, so we can let the auxiliary equation be. So we can let's find the auxiliary equation first. M squared minus 7m plus 12 equals 0. And this can be easily factorized. M minus 3, m minus 4 equal to 0. Equate both factors to 0 and solve. We get m equal to 3, m equal to 4. So therefore, the complementary function is of this form. So the root, notice the rule are real and distinct, right? So we have real roots. Roots are real and distinct. And we have a way of writing these rules. The complementary function is a e to the 3x, where a is a constant, of course, plus b e to the 4x. Now we are told that, so we have noticed on the right hand side, we need to find the particular integral. Alright? Now based on what we have on the right hand side here, the particular integral would be of the form since it's a trigonometric function on the right hand side, would have the form, notice a sin x plus b cos x. Alright, let's find the first and second derivative to substitute in the differential equation now. So let's find dy by dx. So dy by dx is equal to a cos x minus b sin x. Let's find the second derivative also. We'll get the second derivative by differentiating the first derivative. So the second derivative, differentiate a cos x, we'll get minus a sin x, and differentiate minus b sin x, we'll get minus b cos x. And these, we're going to substitute these into the differential equation. We're going to substitute into the differential equation. Let's remind ourselves what the differential equation was again. Here it is. Alright, so the second derivative minus 7 times the first derivative. So the second derivative minus 7 times the first derivative plus 12y equal to sin x minus cos x. Alright, so the second derivative, we have it as minus a sine x minus b cos x. Here it is. Minus 7 times the first derivative. Here's the first derivative. It is a cos x minus b sine x. So remember the 12y. So plus 12y. And 12y, and what is y? Y is a sine x plus b cos x. So 12 into a sine x plus b cos x. And all of that is equal to the left and right hand side here of sine x minus cos x. Now let's expand. So we have minus a sine x minus b cos x minus 7a cos x 7 plus 7b sin x plus 12a sin x plus 12b cos x equal to sin x on the right hand side here, sin x minus cos x. So now we're going to equate coefficients of both the sin x and the cos x. So let's equate coefficients of sin x and cos x. So on the left hand side, let's do the left hand side now. Let's do the sin x first. On the left hand side, for sin x, the left hand side is a minus a. For sin x again, there's a 7b. For sin x again, there's a 12, it should be 12. There's a 12a. And for sin x again, any more? And there's a 12a, that's it. And on the right hand side, it's 1 sin x. Let's deal with the coefficient now for the cos x. So cos x, for the cos x, so there's a minus b on the left. Cos x, we have minus 7a. Cos x anymore, and we have 12b. And on the right hand side is negative 1 cos x, so it's negative 1. Alright, so we have a pair of simultaneous equations that we can solve now. Solve for a and b. Alright, okay, I gotta fix this one. Notice this one, the one for sin x. Sin x. This is actually, so sin x, negative a and 7b, not b. So it should be 7b plus 12a. So 7b. So we have a pair of simultaneous. So this is actually 7b plus 11a equal to 1. And then over here, this is actually minus 7a plus 11b equal to negative 1. So we have a pair of simultaneous, we can solve, we can use elimination method. So let's put them together. So let me call this equation 1, and let me call this equation 2. So this becomes now, this is now, so I'll put them together. So this is, 7b plus 11a equal to 1, and this is well, 11b, put the b on the right, minus 7a equal negative 1. What we can do now is just multiply. I can multiply this by 7, this by 11, alright, before I even get to adding or subtracting. So 7 times 7, that's so 49b plus 77a is equal to 1. Multiply by 11, 49b. It's 11, so that's 121b minus 77a equal minus 11. And I can add, since I can add, 149 and 121 give me how much now? 149 and 121 give me 170, so 170b, and then this eliminated, equal negative 10. So 7 times 1 is 7. Alright. So 7 times 7 plus negative 11, that's negative 4, right? Divide both sides by 170. So b will be negative 4 over 170. I guess we can reduce this to divide by 2 is negative 2 over 85. And of course, now I can substitute this into equation 1. Replace b with negative 2 over 85 in my equation 1. So replace b with negative 2 over 85. So this become 7b. So 7 times 2 over 85 plus 11a equal to 1. 7 times negative 2 over 85. So negative 14 over 85 plus, let's jump in a step there, plus 11a equal to 1. Therefore 11a is equal to 1 plus 14 over 85. Which is 99 over 85. Divide both sides by 11. So a would be 9 over 85. All right. So the solution. So therefore the general solution. Therefore general solution is really the complementary function. Is a complementary function plus the particular integral. Now the complementary function we found earlier was a e to the 3x plus b e to the 4x, and the particular integral was a sin x. Now a is 9 over 85, so it's 9 over 85 sin x, and b was negative 2 over 85, so negative 2 over 85 cos x. And that's it, we're done.